Okay, hi everybody. Welcome to the Menino basement here. Before we jump into sizing our conductors, give you a little view of my basement. There's my kit, and there's my gas stove. And there's my TV. Got everything I need down here. Well, not really, but all right. So enough about me. What we're going to go over today is, I have some people working on the house. Not many, don't worry, and they're corona free. Just a couple carpenters finishing something up. So you're going to hear a compressor kick in probably too. What we're going to go over today is sizing conductors when you have more than 3 conductors in a pipe or raceway. When you have too many conductors in a pipe or raceway, the problem is when you send amperage through a conductor, you get heating in the conductor itself. It heats up. So when you bundle a bunch together, you get more heating. So the code, as you probably figured, has rules regarding that. Very simple formulas. If you can multiply 2 numbers, you're all set. That's it. So it's pretty easy. Don't get overwhelmed by it. You have to do what we call derate the conductors. That's take down the value at which how many amps you could send through that conductor. All right, and this is going to get you through that. So, without further ado, let's go to the worksheet. This is going to be what's going to be out on Mastery Connect. The first 2 questions in each area are going to have examples. So question 11 and 12 and question 1 and 2. Why I say each area is 1 through 10, as it says right up here, it's derating conductors based on the number of conductors in a raceway or cable. 11 through 20, like what you did yesterday, where you derate the conductor based on your ambient. Ambient means surrounding temperature. You take down the amperage value of your conductors based on if it's too hot. All of this is just geared at keeping the insulation not too hot, keeping it cooler. Because when it gets heated up too much over time, it can dry out and then you start to have some problems. So the code makes rules regarding that on things that provide heat to your conductors. One is your amperage going through, limits that. That's what this whole thing is about. And ambient temperatures, and if you group conductors together, that also creates heat. I mean, it makes a lot of sense. When you group a lot of people together in a room, you produce heat too, right? Similar principle in a way, except this is conductors, and they heat up because when you send amperage through a single conductor heats up. How much more if you have 6 or 7 conductors? They're going to heat up and potentially damage the cable. So it's only 3 tables we use. Let's look at the first question. This is one of those ones based on how you derate for more than 3 conductors in a cable or raceway. So this right here, the question is, if you have a pipe run with 4 number 6 AWD THHN conductors, copper conductors in it, installed in an area where the ambient is surrounding air temperature of 85 Fahrenheit. Now that's going to be a normal temperature. It's not going to derate for that. What's the current carrying capacity for each number 6? So this is really just going to derate because of the fact there's more than 3. There's 4. And the air temperature, it's not going to take down any value on the conductors in that because it's 85, and you're going to see that range, just like the example yesterday, is fine. So first thing you have to find out, what are we dealing with? We're dealing with 6 AWG, American wire gauge, THHN copper conductors. So you look in the code. Again, I have the 14 code here. but these tables have not changed. Okay, it is a draft version. It's free out there for public use. At least this was out there. It's right out on the internet. All right, so 310-15B16. What did I say? I said number 6s, THHN. So cross-reference, that's all. Here's our 6 right here. See where my cursor is? Make it bigger. There's 6. Cross-reference with THHN on the copper side. I said they're copper conductors, right? Not aluminum or copper clad. Oh, don't want to do that. I don't know what I just did, but edit. Oh, I know how to fix that. Oh boy. Only when you're trying to do a recording does this happen. All right, there we go. 6. THHN. See how it's 75 amps? That's what this is, by the way. If you look at the top of the table, allowable ampacities. Ampacity, again, was a combination of the two words amps and capacity. Ampacity. Keeps underlining everything. Oh, we'll leave it. Nah. Alright, I don't know what to deal with that, but... Alright, so next. Let's go back to the problem. So we know it's 75 amps to start with. Adjustment factor is based on 310-15B 3A, not 2A. We're going to see that it's 80%, and we'll see what that's all about. Let's go back to the code. 310-15. Here we go, B3A. B3A, another underline, look at that. All right. What are we working with? It said there's 4 conductors, so 4 through 6 right there, right? Percent of values in 310-15, B16 through B19 as adjusted for ambient temperature if necessary. So we're working with 310-15, B16. So percent of the value we just found, that was 75, right? The table we just looked at. If we have 4 conductors, looking up in this table, we have to multiply it by 80%. So all you do, go to the first table, that's 310-15 B16, find your amperage rating for what you're working with. Ours was THHN, number 6s, copper. That brought me to 75 amps from this table right here. Then we went to this table because we have more than 3 current carrying conductors. Grounding conductor doesn't count as current carrying, by the way. It only carries current on a fault. 4 to 6, 80%. So let's do the math. Look at that. I have the math done for you already. 75 amps times 0.80 equals 60 amps. So what this is basically the answer to this. 60 amps is the answer. That wire used to be good for 75 amps. It's now only good for 60 amps because there's grouped wires together and it can heat up. And over time, it's not going to happen overnight, but over years, you could get drying of the insulation, then you have an issue. All right? And the second one is basically the same thing, except there's 7 number 6s right there. So same thing. We go back. Let's go to that table. 7 through 9. See how it gets you in a different category? 70%. So it said to start off with a number 6 was the example. Number 6, THHN. There's 7 of them. Take it at 7%. So let's go back to there. Number 6 THHN was 75 amps. Multiplied by 70%, 0.70 to do that, equals 52.5 amps. And that's my answer. That wire now is only rated at 52.5 amps. That's the ampacity, the current carrying capacity of that wire. Further down, so that's 1 through 10 are done just like that. If you do it just the way I said, just like that, you shouldn't have any problem. Just look it up in first table, 310, 15B, 16, get the amperage. Look it up in the second table, get your multiplier, and that's going to show you what that wire is then good for. 11 through 20 are just like what you did yesterday. It says if you have a pipe with 3 number 6s in it installed in an area where the ambient temperature is 85, what's the carrying capacity for each number 6? Now, this one we use a different table for. We use the same one we used yesterday, which is B2A. Again, go to B2A, not B2B. B2B is something different. We want B2A table, B2A. And what do we say? 85 Fahrenheit. So right here, carry that over. See how the multiplier is 1. So in other words, they're saying for 78 to 86, you don't have to derate and take the value down because anything times 1 is itself. So in other words, start off with 75 amps. You're putting it in an area that's 85 degrees. It's not going to affect the insulation and hurt it over time. It's never going to hurt it. That's just a comfortable temperature. So the multiplier is 1, 75 times 1, and I think you all know this, but I put it in anyway, that asterisk means multiplication. 75 times 1 is 75. So that's remained the same. But the second one is also 6 THHN conductors. And it says the ambient or surrounding temperature is 88 Fahrenheit. Got an edit problem there. I think it has to be capitalized. Look at that. All right. 88. So let's go back to the code. Let's look up 88. 88 is within the range of 87 to 95. 0.96 is our multiplier. See how it's right there, 0.96. 75 amps times 0.96 for our multiplier that we're derating, taking down the value according to. In other words, you're taking that wire only has 0.96 percentage of its original ampacity, current carrying capacity. And it's 72 amps. That wire is now only good for 72 amps because it's in an 88 Fahrenheit area. It's a little warm. So you have to take down the amount of amps you send through the conductor, or are allowed to send through the conductor, so that the internal heating of that will not heat up the wire too much. So it's called, electricians call it derating. All right, and this didn't have more than 3, that's why it didn't do the other one. Yes, you can do both of them if you need to, and there are going to be cases like that where we have like 6 wires and 90 degrees, and you have to do both mathematical equations. It doesn't matter the order, but both of those, not either, both, would work if you have a condition with over 3 and over your, what was it, 86? Yes, over 86. And again, like I said in the other video, these multipliers for under 78 to 86, you actually multiply by a higher percentage. It actually raises the current carrying capacity of that conductor. Like if you were doing work in a cooler or something like that, it does raise it. Just a nice little thing to know. All right. Hopefully that helps. Post any questions. I know this is new, but electricians need to know this, and electricians do this. I can answer your questions with the group, or if you have something one-on-one you want to post to me, do it in the one-on-one section I created. And do 5 IXL questions. This is what our grade's based on, so you have to do that, all right? It's based on watching these lectures, doing the IXL, doing the worksheets that I think for this point are going to be Mastery Connect and attendance as well. And hang in there. This won't last forever. Okay. I'll talk to you soon. Bye-bye.